Now we are having different types of inheritances, like say single inheritancy that we have already seen right now. Okay, so this is a single inheritancy where one class is acting as a parent class, one class is acting as a child class. Then second option is multiple inheritancy, where a class inherits multiple base classes, okay, more than one base classes. Then multi-level inheritancy. In this case, we are creating like parent, child, and grandchild kind of relationship. Means one class, child of that class, and grandchild of that class. Okay, so this way we are creating multi-level inheritancy. Hierarchical inheritancy. In this case, one class is having multiple child classes. Okay, means multiple derived classes over there. And then hybrid inheritancy, which is a combination of all these types of inheritance, like diamond shaped type of inheritance here. Okay. So first we'll go with multi-level inheritancy, how we can imply this multi-level inheritancy. We'll see one example of it. We'll write one class, quad class, that is to represent a quadrilateral. Okay, so inside this class, we just want to define four sides, S1, S2, S3, S4. We'll write one init function to initialize these four sides, and we will calculate perimeter and print. So first we'll write init method through which we can initialize these four sides. So here we are passing four parameters like A, B, C, D, and here we are initializing these values of sides here. Okay, sides we are defining as S1, S2, S3, S4. And we initialize it through this init method by these parameters A, B, C, D. Okay, so this is init function. Here we define four attributes S1, S2, S3, S4. Then we are writing one method perimeter to calculate perimeter of quadrilateral. So here we calculate perimeter by just adding side values like this. Sorry, it should be self dot S1, self dot S2 plus self dot S3 plus self dot S4. So this is how we can calculate perimeter, and that we are printing here. So we are having one quad class which represents one quadrilateral, contains four side values S1, S2, S3, S4, one perimeter method by which we are calculating perimeter and printing it. Now we want to define the rectangle. So rectangle class we inherit from quad class here. So we implement this inheritance by this syntax. Now in case of rectangle, we are having only two values, length and width, through which we can initialize this all four sides here. So for that purpose, see how we are writing constructor of rectangle now. Here we are passing only two parameters now, A, B, and we are calling this parent class constructor by using super method. Here we are calling this constructor, and to this constructor we are passing this A, B twice. Okay. To this parent class constructor we are passing this AB twice, so that it will initialize all these four properties S1, S2, S3, S4. And now we want to calculate area of rectangle. So for that purpose we are writing area method over here. Area we can calculate like this. See, self dot S1 into self dot S2. So that will be area, so that we are printing here. So this is single inheritancy. One quad class is there and one rect class which is child of quad class. Now we want to define multi-level type of inheritancy. So we'll create another derived class of this rect class. So here we are writing another class, that is square, which is now child of this rect class here. So now this becomes multi-level type of inheritancy. One quad which is acting as a parent, rect is a child of quad, and square is a child of rect class here. Okay, so in case of square we want to define square by using one only single value. So here to init method we are passing only one parameter value. To this one parameter value we are invoking this super init method, and see here we are passing this value twice over here. See how we are invoking this parent class init method everywhere. So to square we pass only one value. That value we copied twice over here, so it comes over here, and from here we copied it twice once again, so it initializes all four sides of square or rectangle or quadrilateral. Okay, and here also we are writing area method, just printing area like this, self dot s1 power 2. So So this is multi-level kind of inheritance. See, while creating object, here we are creating object of square by providing some value 10, and then we are calling this perimeter method and area method to print area and perimeter. So it will be get printed on your screen. The output is not important. See how we manage multi-level inheritance by using these three class: quad, rect, and square. I'll see multiple inheritance. In case of multiple inheritance, there are more than one base classes and one derived class, like how you can see in this image. Okay, this inheritance we write somewhat like this: class, derived, and in parentheses we write down all these parent class names separated by comma here. Okay, so let's see one small example. See here we are writing one class name as a father. To this class we want to define name of father, so that we are defining by using this init method, passing parameter over here, and this attribute we define as f name that we initialize over here. Okay, then we are writing one method f print by which we just print this father name on screen, saying self dot f name. This whole class we copy, write it now as a mother. Just make changes everywhere. Instead of f everywhere we use letter m now. So this is a mother class by which we are just defining name of mother. So these are two separate classes. Now we define one class name as a daughter, and this class is child of this mother class and father class. So this is multiple inheritance. This is multiple inheritance. Now we're defining init method of this class. So to this init method we are passing f name and m name, means mother name and father name. Now see, we want to invoke parent class init method through this init method of daughter class here, but we can't use super now because super is confusing. It will not come to know which init method we are calling, from mother or from father. So instead of that, we directly call init method by name of class here. That option we have seen. If you are calling init method like this, we need to pass this self parameter also here. Here we are calling init method of mother, and here we are calling init method of father class. Okay, and here we are passing f name. So this is multiple type of inheritance: two parent, father, mother, and one child, daughter. So here we are creating object of daughter class by passing two parameters, two arguments rather, name of mother and name of father, and here we are calling this print and mprint method. It will print mother name, father name on screen here. So this is how we can implement multiple inheritance. Now see, there can be a possibility of conflict if you come with this multiple inheritance. Suppose say instead of print and mprint, if we write method name as a print only, then confusion is that when we are calling this print method over here, there is possibility that this print method is from father also and from mother also. So when you run this code, now it is printing name of mother, so that suggests that this print method is from mother class. Okay, why? Because while inheriting we have written name of mother class first here. So if you change this sequence here, if suppose if you write name of father first and name of mother class afterwards, now see, now if you run this code, it is printing name of father. It means that it is calling method of father class here. So this conflict arises when methods are having same name. Okay, this is where a concept of multiple resolution order comes into play. Okay, multiple resolution order, or in short form we say MRO. The MRO of a child class is what decides where Python will look for given method and which method will be called when there is a conflict here. Okay, so see, there is one MRO method also. You can call it like this: name of a class dot MRO. So MRO tells how this method will be get searched. See here, it is printing name of classes. So first class will be daughter, means whenever you call this print method, it will be get first search in daughter, means if you're having print method in daughter, that will be get invoked first. Next it is searching in father class, next it is searching in mother class, and finally it will go for object class, which is a parent of every other class here. So this is a searching sequence that depends completely on how you are writing, and what is sequence of writing class names over here. Okay, so this is a multiple kind of inheritance.